Hey guys, how you doing? This is Guy here. Welcome to this live. Today, Sunday, April 13th, 2025. I'm here again live like I do every Sunday, and my goal is to bring you in my lab, do things with you, show you what I'm learning, show you what I know, and just to help you start or boost your career. That's the goal I created KB Trainings for. Thank you so much. Thank you for saying chat. Thank you for saying hi in the chat. That's what I meant. Raphael. Thank you, Raphael. Where are you watching me from? Just to leave a quick note in the chat. All right, so we are live on Facebook as well. And please make sure you like the video and you also share it with your community. If you like these kind of videos, make sure you subscribe to the channel as well. I go live every Sunday. I create videos out of nowhere during the week if I have something very fun to share with you. Today, we're going to talk about DHCP snooping. It's a good security measure that you can take at layer 2 on your network just to make sure that you are protected against all kind of DHCP attacks. I'm going to explain to you exactly how DHCP works because all of this is based on the actual DHCP process because it's good, it's fine, it works well in the network, but you always have to be mindful of security when you are deploying or designing a network because there's always going to be bad actors out there ready to jump into your network and just to create a mess. So we're going to explain exactly how DHCP works and what DHCP snooping will help you prevent the kind of attacks you can have, like DHCP spoofing. And from there, I'm going to jump into GNS3. We're going to do a quick lab where I'm going to show you the configuration of DHCP snooping. All of this is kind of part of my CCNA training that I have on KBTrainings.com. If you go on my website, en.kbtrainings.com, you're going to see the best CCNA training online. It's mine and it's over there. And also, it's the best, not only because the content is good, but because every 2 Saturdays I go live with you. I talk to you. Like we talk live. You ask your questions. We talk about how to place yourself in a marketplace and all kind of good stuff that you get. So you get literally access to me every 2 weeks live. All right, guys. Raphael, Peiba, I'm a member of your course. Oh, okay, Raphael, I remember you. We met last time. Okay, perfect. Good to know that. Here again. What about you, Linux? Where are you from, Linux? Watching from New York. Tech Kid Francis. Perfect. Thank you so much. Thank you for all the support, and thank you for all you do. So this is a design that I just made up right now, just to explain to you what we're going to talk about today. Like I said, we'll be talking about DHCP snooping. And here is a quick design, very small design with a switch in the middle. And we have our default gateway. And we also have this good guy sitting here. His name is Guy. Guy are always good guys. Like if you've met a guy called Guy, he's a good guy. And then there is this guy here. This is the bad guy. So that's why his computer is a little, I don't know, old, like an old terminal. This guy is called Tom. So Guy actually is a member of this network, which is supposed to be a very simple network with a DHCP server here and a DNS server in this same box. And then we have our default gateway going out to the internet with our ISP. So in reality, it was just business as usual. Guy connects to the network. He needs an IP address, and that's where we use this protocol, Dynamic Host Configuration Protocol, DHCP. It's meant to give us an IP address automatically without manually configuring it, which will take a lot. If you are in a huge network with thousands of endpoints, you'll have to go one by one. Usually, you can manually configure your main servers, the ones that you don't want to change. Like in my home network, the big Windows computer that I have here, that's where I do all these lives and I do a bunch of things on it. That computer has a static IP on it, so it's never going to change. But any other thing in network can change because if you shut down a device for a long time, if it comes back, it may change the IP address. So dynamically, we should have an IP here. So how does DHCP work? And that's something, like I said, we've seen in the CCNA course, but also I can just repeat it here quickly. DHCP is going to start from the client. On the port 68, the client will send a discover packet. It's called discover. I think I've mentioned DORA in the past. If you've heard me talking about DHCP, I have this DORA. It's my own way to remember the DHCP process. So there is a discover, there's an offer, there's a request, and there is an acknowledgement. So what happens is that the computer is going to send a discover. The discover is a broadcast. So the computer would say, hey, I'm here, I need an IP address. And when the switch receives the broadcast, by default, the switch is supposed to flood the broadcast to all the different interfaces, of course, excluding the interface from which it came from. So at this point, our discover is going to be sent to this link, to that link, and all the way down to the link where the bad guy, Tom, is sitting there. Actually, I think I can do justice to Tom. Let me put it in red, because Tom is not good. So he's sitting here. And what we don't know is that Tom also enabled DHCP on this laptop. Even though we have a DHCP here, this is supposed to be green, listening on port 67, Tom also has a port 67 open on this computer. It's actually very easy to deploy a rogue DHCP. This is a rogue DHCP. You can do it on like a Linux computer or any kind of, there are many ways to do it. You don't want to become Tom, so I'm not going to teach you that. So he's sitting here with his computer listening on the port 67. He already has DHCP enabled here. So what's going to happen is that when that packet is sent, the discover is sent as a broadcast. The next step is the offer. So the DHCP server is supposed to offer an IP to our device. The offer, good thing is an offer is a unicast. It's not a broadcast. So the offer is only sent to Guy, and Guy receives the offer. The computer is like, hey, I'm going to give you, let's say our default gateway is 10.0.0.1. And Tom was able to get for himself 10.0.0.250. And our DHCP and DNS is sitting on 10.0.0.2. So this computer is like, hey, Guy, I am offering you 10.0.0.10, for example, and your default gateway is 10.0.0.1. This is the offer, the O in DORA. And then there is the request. When Guy receives that offer, Guy has the option to either request it or decline it. But in my case, I'm going to request it. I'm like, hey, I send a request, send me that IP. And the good thing is, it's not that good of a thing, but the request is usually a broadcast as well. It's typically a broadcast. So Guy is going to send another broadcast. And by the way, I'm going to tell you what Tom is doing in the meantime. So Guy is going to send another broadcast to this server and be like, hey, send me that IP address. And of course, it's a broadcast. Tom is going to receive a copy, and the real DHCP is going to receive a copy as well. So the real DHCP is going to be like, hey, okay, this is the IP, get it. That is the acknowledgement part. And then I am going to be set with 10.0.0.10. So it works fine. It's okay in a normal network. But in a network where we are already attacked by Tom, and that is not unusual. We talked about ZTA or Zero Trust access on this channel in one of my old lives. That's where everything goes these days. You can't just live as if you are fine, as if you're living in utopia where there are no attackers, no hackers. You need to be aware of it. ZTA, one of the principles of ZTA is assume breach, which means that you need to assume that you are being breached all the time. You need to assume that there is a hacker living in your network. And like in this case, for example, Tom is sitting here. What is going to happen first? First, he sees the discover coming from Guy. He knows that Guy is looking for an IP address. What can he do? He can actually respond to that discover with his own offer, sending the offer to Guy. And the problem is that he can try to take over Guy's traffic by providing false information. Let's say it's responding, even though it's in the same network, he's going to tell Guy, hey Guy, your IP is 10.0.0.251 and your default gateway is 10.0.0.250. 250, and your DNS is 10.0.0.250. See the problem here? He's giving him false information, and then Guy will have this wrong IP. Guy is going to have Tom's IP as the default gateway. So if I can clean this up, what's going to happen in that case is that Guy will have his traffic. He will send the traffic to Tom thinking that the traffic is going to the default gateway, but Tom will have to intercept this traffic, read the content, take the traffic, send it to the actual default gateway, and then out to the internet. This is Tom becoming the man in the middle. This is an attack, a common attack that you find in networks, a cybersecurity attack where a bad actor places himself between you and the asset you're trying to reach, and he will be able to see your traffic. He may even be very creative to the point where he's going to decrypt your SSL sessions, read everything, encrypt it again, and send to your default gateway. So by then, he will be seeing everything you do. He can steal information. You there, Guy's there working, trying to make his paycheck, but Tom is out there just going the shortcut, trying to make millions by stealing information from the company and then maybe sell it on the internet or whatever. So this is a man-in-the-middle attack. That is first. That is one of the risks that you can have if you don't have DHCP snooping enabled. And I'm going to tell you how DHCP snooping is going to protect this. Second thing that can happen is that we don't only have DORA. DHCP has a lot of types of packets that he can send. Another type is release, for example. A DHCP release is what a computer is sending to the server to tell it to release an IP. Let's say this server gave me 10.0.0.10. At some point, if I don't use it anymore, I can send a release packet to say, hey, release this IP. What if I'm not the one sending it? Because remember, even if Tom didn't give me an IP, Tom also saw my request. Tom saw that, Guy is on 10.0.0.10. Tom can be now messing with the network by sending releases for this IP. So my server will have 10.0.0.10 available and can assign it to other computers, and that will become a problem because we're going to have duplicates. That's also another kind of attack that you can have in a network where a bad actor is now sending one or a ton of release packets to our server, and our server can be even overwhelmed, but also our server can now start duplicating IPs inside the network by not knowing what's going on. That's what a guy can do in your network, and you don't want that to happen. So what is the solution? DHCP snooping. I don't know. Do you think I'm going fast or it's okay? I mean, it should be okay. But if you think it's fast, then you need to go to the CCNA course. Watching from Kinshasa, Glory Moose. Oh, Glory, how are you doing? Hello, coach. Thank you for your abnegation. Yep, I'm here for you. Thank you so much. Have you done any project or video on SD1 watching from Ghana? Oh, Linux at IT for me. Yeah, of course. I do it SD1 all day, every day. That's actually, let me show you this. Maybe I'm not going to get derailed here. But anyway, yeah, I do SD1 all the time, mostly on the Fortinet side because that's what I do for my customers. And also, I'm going to create videos about it. I can do it on Meraki. I can do it on anything. Actually, I have 2 MX64 here. This is part of another network or another project that I have. I need to build an SD1 with Meraki to showcase some good stuff. So yeah, I can do it on that as well. And of course, I can bring you all of that on the website. So make sure you are on en.kbtrainings.com. At least you are in the newsletter or the mailing list. So if there's anything new, I'll let you know. Good, past it, did not use my default gateway address. Yeah, exactly. So Raphael says it's good. Okay, so we can keep going now. This is what can happen, and you don't want it to happen. And the solution, like I said, the solution is DHCP snooping. What is DHCP snooping? That is when you, as a network administrator, instruct your switch to behave differently. First of all, I told you that when a discovery is coming as a broadcast, everybody will know about it, right? So now we're going to change the way it works. The switch is going to have port or interfaces divided in 2 categories: trusted trusted and untrusted. Let's actually be a little thoughtful here. And since I can change colors, I'm going to do trusted in green and untrusted. So now we have two types of port, trusted and untrusted. And I think you can guess from this point. The trusted port will be the port that is connected to our real DHCP server or to the infrastructure where there is DHCP, where we are supposed to see traffic for DHCP. That is the trusted port. All the other port are untrusted. Untrusted means that the switch is going to discard everything that is coming from that interface that has something to do with DHCP. If it's like an offer, because only the DHCP server can send an offer, the switch will only receive offers and acknowledgement from the trusted port. But still, GI will still be able to get an IP because the switch can accept discovers. But instead of sending the discovers everywhere and let Tom know of what's going on, the switch is only going to send discovers to trusted ports. So in our case here, for example, where are going to be our trusted port? The trusted port will be here, okay? And then untrusted port are here, there, and there. And the principle is that a discover that is coming on an untrusted port will never be sent to another untrusted port. It will only be sent to a trusted port. That's it. That's how you protect your network. And also, that's first. So first, Tom is going to be sitting here. He's not going to see any discover from anybody because he's sitting on the wrong port. He's on the wrong side of history, right? So he's not going to see anything, but only our DHCP server would see it. That's first, okay? Trusted and untrusted. The second thing that DHCP snooping does for you is that it's going to create a database. That database is going to match IPs to MAC addresses to ports. So when our computer is going to get its IP assigned from the DHCP, the switch is going to make note of that. It's going to say GI with the IP X with the MAC address X is sitting on the port X. What does this prevent? Let's say, for example, now Tom somehow knows that GI has 10.0.0.10, and now Tom is trying to send the release packet. The switch is going to receive it. It's like, hey, you are trying to you're pretending to be 10.0.0.0. It's going to check the binding table. That's how you call it, the binding database. It's going to check it. It's like, hey, no, 10.0.0.0 is supposed to be on the port X. Why are you now coming from this different port? I'm not going to forward that packet. This is a very good measure that you can take in your network that nobody is going to impersonate another computer. So now it's all locked, and the guy, Tom, will go out of business because he can't do anything in your network anymore. This database is actually very good because it's also going to be used for DAI or dynamic ARP inspection, because when ARPs are coming, we can see who's requesting what and if they're on the right port. That's another topic for another day. So this is how I can explain DHCP snooping to you. It's going to help you protect your network against DHCP spoofing attacks and all kinds of DHCP related attacks inside your network. I think we're good there. I use FortiGate at my job. Thank you for all the great FortiGate videos. Thank you. It's my pleasure. QCNS LLC. Raphael. Okay. All right. And also, this is a feature that you find on a lot of devices. Let me actually show you, because I get a lot of questions from people that are studying for the CCNA. It's like, hey, what if I'm studying for the CCNA and then I go in production and I find a company that is not using Cisco? What am I going to do? Am I screwed? No, you're not. The thing is that the CCNA is going to teach you a lot of things that you can apply on any vendor. That's why I've always said, if you know how to use Cisco, you can use any other device out there, or if you have the CCNA, because the CCNA will teach you a lot. If I go in my home FortiGate here, let me show you one quick thing. I'm on the 40 switch ports. Let me just make sure. Okay. These are my 40 switch ports. Look at this. If I do a right click on any of these port here, if you look down here, you have um, DHCP Snooping. So it's asking me if I want to make this port trusted or untrusted. Right now, apparently it's untrusted. That's what I'm saying. And it's also down. So this is just me showing you an example of DHCP snooping on a 40 gate. So it's an option that you're going to find on all the vendors. Aruba, if you are dealing with Unify or whatever switch you're using, Juniper or whatever, you're going to see this option. So now you know what it is, you know what it's there for, and I'm going to show you how to configure it on a Cisco switch. Next, let's go in GNS3 as always. One thing is, I just did the same live in French, but first I was planning to do the live on Packet Tracer. Then I discovered a big bug with Packet Tracer. Packet Tracer doesn't work properly when it comes to DHCP snooping. When Packet Tracer is supposed to block discoverers from going to untrusted port, it was actually doing it in Packet Tracer. So I didn't know. I even started doubting myself. I thought maybe I knew the wrong information. So I opened GNS3 and it works perfectly in GNS3. We're going to see it really soon. So let's go ahead and create our quick topology. I'm going to have a device here, like our actual test PC. And then I'm going to have a Cisco switch. I'm going to call it switch. Yeah, let's just call it switch. And then I will have 2 routers. And these 2 routers are going to be our DHCP servers. So this one, I'm going to call it good DHCP. It's invalid because I put the underscore there. Good. Can I do a dash DHCP? Okay. And then this one, I'm going to call it, let me see if you can, I don't know if you can see this, but yeah. This one, I'm going to call it bad DHCP or rogue DHCP. I mean, you understand what I mean. So let me connect these different ports here. And what I love about GNS3 is that I can do packet captures on using Wireshark. So we're going to see exactly what's happening in our network. All right, so we have this set. Do I have packet tracer or Wireshark enabled right now? No, I don't. All right, so let's go ahead and tune on this topology. Oh, I can just add a quick notes, okay, just to make sure we are good. My network is 10.0.0.0/24, and the good DHCP is sitting on 10.0.0.1, and the bad DHCP will be sitting or giving itself 10.0.0.250. All right, and that is this port here, and that is that port. So let's turn this on. Rabeg, hello, Rabed Mohammed Ali. Could you assist me in getting 40-gate 40F VPN working? I can, but how? I don't know. Unless we have like a private meeting where I can take a look. But I've made videos on VPN on this channel. So just look around. You'll find a video where I talked about VPN. Is it IPsec or SSL? Yeah, I've talked about this. And also, I am planning to have a lot of Fortinet trainings on KBTrainings.com. This here. Let me show you this. This here is part of my mega lab where I'm building this whole thing here. It's already built actually. Oh, by the way, this one changed. It's not an 81F anymore. It's a 91G. So I have a 91G as the hub in my data center deployment. And behind it, I have NAC, I have FortiManager, FortiAnalyzer, FortiAuthenticator, FortiMail, FortiGuy, because I'm a Forti guy. Yeah, everything is there. SD1, ADVPN between the sites. So all of that, I'm building it for myself, but also, of course, I'm going to share it with you. So yeah, make sure you are in my newsletter. When the training is ready, I'm gonna show you, let you know. I can contact you on LinkedIn. You can just send me an email. It's actually better at contact. Let me put it in the chat. Contact at KBTrainings.com. If it's a quick question where I can just take a look and respond, I'll do that. If it takes me time, I'll probably not. But send me some details there. If you can put some topology or some whatever you can provide to me so I can know what you're doing. And yeah, I can literally do that for you. Also, some people like to contact me on Instagram. If you go on KB Trainings on Instagram, you can send me a voice note or something. I'm going to read it and respond to you. It's actually also a good option. All right, let's go ahead and continue this. We are here. What's next? Let's go and configure our good DHCP. It's open back here. I think you can see everything well. Let me increase the size a little bit. No, down, more, down. All right, I hope this is good. On the good DHCP server, like I said, we're going to give it an IP address, interface gig. What? Oh, okay. It was not typing. Interface gig 1.0. IP address will be 10.0.0.1/24 to open. And that'll be good for now. Logging synchronous just to make sure I'm not going to get bored by those things. We will do the DHCP configuration later. Okay, there's this thing with this switch where it's always mismatching the duplex. And we're going to fix that later. Let's go to our bad DHCP. Configure terminal, interface gig 10, IP address 10.0.0.250, /24, no shut. Oh, I didn't get out. Line console 0. Login synchronous. All right. So now let's go to the switch because I have that mismatch thing that is happening on the switch. I need to make sure that our switch has a full duplex on all the ports. As you can see here, the message is saying that we have health duplex on the switches. On the switch ports. So we can go inside the interfaces. What am I using now? I'm using 01, 0001 and 02. I can do interface range, gigabit 01 to 2. No. 0 to 2. And I'm going to do no negotiation auto. And then I can then do duplex full. All right, that's it. We're going to get rid of those messages. Line console 0, logging synchronous. That was just the beginning to set us up. If you're familiar with Cisco, that was just very simple. What I did, I put the IP addresses on the different ports, and then I was able to also fix the problem with the duplex mismatch. So next thing I'm going to do is also, because we are on packet tracer, let's also launch some packet captures. I'm going to launch a packet capture from here. Oh, sorry. I meant to say we are on PC1. We are on GNS3. So I'm going to name it PC1 and I'll do OK. So it's going to start a capture for PC1. I'm just going to push it somewhere on the side here. And of course, I like to get rid of the noise, like the spanning tree stuff and everything. I don't like to see all of that. So you can build a filter to filter out all this noise by, let's say, for spanning tree, I can come over here. I pick a spanning tree packet and I go here where it says spanning tree. I do a right click and do filter not selected. Okay, so it's gonna filter out all the spanning tree. Now I need to filter out CDP, VTP, and DTP. I can do right click here and filter out, filter as, and not selected. Okay, so now we only have CDP. Let me also filter out CDP. Right click, filter as, and not selected. Okay, now we can actually grab, there's one more thing that would, yeah, let's grab this filter. I'm going to use it. Oh, sorry, you don't see it. So I'm just copying the filter the way it's written here in Wireshark. We're going to use it elsewhere as well. So that was first. Second, let's also launch another packet capture going to the good DHCP. We are launching it. I'm going to call it only good DHCP. All right, and I'm gonna hit OK. It starts. I just make sure it's right here at the corner. And also I'm going to put that filter in here so we don't see all the noise. Okay, there was the loop. This was the one that I missed. So I can come here and how do I see it actually? Ethernet configuration. I can just grab this thing and do right click and do and not selected. All right, it's gone. So this is the full filter that I need. I can also grab my other PC1 capture and add the filter for the loop to it so we don't have that bothering us. Like I said, we have two captures right now, the good DHCP and the PC1. So let's now do another capture here. Start capture. I'm just gonna call it bad DHCP. I don't even know if this name thing is gonna help, but I always like to do it. And then we're gonna put our filter here, so we filter out all the noise, and that is good. So my goal is to have all three of them showing on this screen. So we have the good DHCP, we have the bad here, and we're only missing the computer. Okay, now we have PC, good DHCP, and bad DHCP. Let's go back here. And now what I'm going to do is configure DHCP on both of these routers. They'll be able to deliver the information to our device, and you're gonna see how I can tweak it so that they're gonna be different. So on the good DHCP, let's go ahead and configure that. We're gonna do configure terminal, IP DHCP pool test. I can go inside. I need to define the network. It's going to be 10.0.0.0/24. I need to define the default gateway 10.0.0.1. This is where the attacker can change the default gateway and give us another one. So the default gateway is there. The DNS server is 10.0.0.1. And then we can do the lease. How many days? Let's do just 1 day for the lease. And then we can do the domain name. We can call it en.kbtrainings.com. This is the domain name that's going to be given to the device. And then end. That should be it for DHCP configuration. We can do show run. Actually, I can also exclude some IPs. Configure terminal, IP, DHCP, exclude addresses. I can do 10.0.0.1 to 10.0.0.10. So my computer will start having IPs from 10 all the way up. And that's it. And I like to do copy running config to start config. So it's supposed to be like this. All right, I'm just saving what I did here. So let's go ahead and do the same thing on the bad DHCP server. Configure terminal, IP DHCP pool test as well. Network 10.0.0.0/24. Default gateway, this is where we are in business. So it's 0.0.250. That's the wrong one. And then I can do DNS server 10.0.0.250. And you understand that even with the DNS server, it can be a big problem because if now your attacker has given a wrong DHCP or DNS server to your client, now he can give them wrong IPs to website. Let's say they want to go to google.com and the rogue DNS is going to receive the request. It's going to give them a wrong IP to a bad website, a staged website where they can go in and just see the login page for Google. And then they're going to put their credentials and there's somebody just collecting all those credentials. And that's not good. So it's really important to get all of that settled. So we have a DNS. I can do the lease for 1 day. And I can do the domain name en.kbtrainings.com. That's it. We can do exit from here. And I can do IP DHCP exclude 10.0.0.1 all the way to 10.0.0.150 just to make it different. So our bad DHCP will start with 150. And I can do end here. So right now, let's see if we have anything of value that happened in our DHCP or packet captures. We don't have much. I have this DEC mop here. I don't know what this is. Let me just filter it out. What the hell is this? Data frame. How do I filter this thing out? Type. Okay, I can go from this type and I can right click on it and add it to the filter. Apply as and not selected. Okay, it's out. So I can just grab. Did I do the right thing here? I just hope it's not gonna filter out something that is important to me. So I put that filter everywhere. So now we should be able to see all that noise. So what we're gonna do now is open our PC1, okay? We're just gonna keep it somewhere here in the corner. Let me move it here so I can do this, that, and that. Okay, so my PC is here. What I'm gonna do is do IP DHCP. What are we supposed to see here? Normally, because I still don't have DHCP enabled, what I'm supposed to see is some discover packet from the PC. So the PC, we're going to see a discover packet here. We are going to see the same discover being sent here and there. So the good DHCP and the bad DHCP are going to receive that discover. And one of them, or both of them actually, will respond with an offer. And the computer will request the service, the IP. And one of these two guys is going to give him an IP. So let's go ahead and launch that command and see how the packets will be seen here. That's what I love about GNS3. We have everything clear. So we have the broadcast, we have the ARP, we have the discovers, we have the offers, we have everything happening. All right, first of all, what I'm seeing is actually not good because apparently, let's see what offer we accepted. I'm saying just not good in the way that I feel like the bad DHCP is winning right now. So if I do show IP, oh, okay, good thing. We received the IP from the good DHCP. Why? Because it starts with 11. We have our domain name set correctly. We have our default gateway set correctly. The DNS is also good. So that's a good thing. And what could have happened is that we could have seen 151 here and then 250 there, 250 there, which is bad. Usually with all the operating systems, if a computer receives more than one offer, it's going to only grab the first one. The one that comes first, it's going to grab it. All the other ones will be rejected. But for our investigation here, or just to be, I'm just curious, I can go over these different packets here. This first one that you see is a discover that the computer sent. And that discover was sent to everybody. The good DHCP received it. The bad DHCP received it. At the same time, our computer also sent an ARP. I don't even know what the ARP was there for, but anyway. What I want you to notice is that this is like the name says here, a discover. We can scroll on the side. Oh no, not there. Here, you can see it says DHCP discover. So now look at this. it received two offers. One offer from the good DHCP, another offer from the bad DHCP, because the bad DHCP was also aware of the transaction going on here. But the good thing is that the bad DHCP came second. That's why it was not considered. And then our device only requested the IP from the good DHCP, and that's how it got it. That's how it happened. And you can follow all of this here. This is the offer that we sent, and then what is this other one? Oh no, that was a discover, and then we have the offer that we sent to it, and we didn't actually receive it. Anyway, so now I'm going to enable DHCP snooping. Oh, I was showing you something that you were not able to see. I'm sorry. I'm going to enable DHCP snooping. All right, let's go in the switch. We are going to open the switch, and I'm going to do enable configure terminal. Host name, let's call it switch. I want to show you some cool stuff first. Let's see if I do show IP DHCP binding. There's no information here. This is the binding. Thing. Wait. Show IP DHCP snooping. Okay, binding. That's what I meant. We don't have any information here for DHCP snooping. If we do show IP DHCP snooping database, we have nothing in the database. It's all zero everywhere. So what I'm going to do now is enable DHCP binding. I'm going to do IP DHCP binding in the global config mode. Oh, no, sorry. DHCP snooping in the global config mode. And now that I've done that, the next thing is to enable DHCP on my VLAN 1, because we only have a VLAN 1 show IP, do show VLAN brief. All our ports are part of the VLAN number 1. So the port, and what's going to happen is that when we enable DHCP snooping on VLAN 1, all these ports are going to be untrusted, and we'll have to manually pick the ports that we want to trust. So what I'm going to do to enable that, I'll do IP DHCP snooping VLAN 1. And let me show you this. I want to show you one command before I enable this. If I do show IP DHCP snooping, look, it's not enabled. It says DHCP snooping is operational on VLAN none. There's nothing enabled there. So let's do IP DHCP snooping VLAN 1. And if we do that same command, you're going to see that DHCP snooping is configured on the VLAN number 1. DHCP snooping is operational on VLAN number 1. It's configured on the following L3 interfaces. Anyway, so yeah, that's good. So we have DHCP enabled. Now what we have to do next is to trust the port that is going to the good DHCP. What is that port again? Let me go back here. That is the port gigabit 00. So we need to go under interface gigabit 00 and do IP DHCP snooping trust. And then we can end there. So we trusted our interface going to the right DHCP. So what we can do is show IP DHCP snooping database. There isn't much going on in the database yet because we don't have a lot happening. I can do show IP DHCP snooping only. I already showed you this. We have VLAN 1, but we also now have the port here that is trusted. A rate limit is another security measure that you can put in place if you don't want to be attacked by having trillions of DHCP messages coming on a port. You can limit the rate. That's also one way to protect yourself, because you can get some kind of denial of service attack where you get too many packets. So this is packet per second. You can limit the rate. Anyway, Okay, so with that being set on our network, we are now protected by DHCP snooping. Let me show you how it's gonna work. Of course, we still have our packet capture. This is the good DHCP. That is the bad DHCP, and this is the device. Let's just clear everything here. How do I clear everything? I forgot Wireshark how to clear stuff. Um, I can do restart. Oh Jesus, I think I did something. Oh yeah, now I need to go restart again from there. Let's just go from where we are. We are, and we are going to limit it. So let me restart. Let me stop capture here and restart a new one. Okay, I need to put those filters again. Where are they? Right there. Okay. All right. Okay, so we're gonna see from here. We know that this is where we stopped. I don't know. Do you know any way that I can just hide these old ones? Anyway, yeah. I'm going to redo the same thing on my computer. I'm gonna reduce it down here and go back to my PC one, and we'll do IP DHCP again. It's going to send a discover. I receive an offer, and I get it. Something is off. Something is off. Okay, first of all, at least we can see that it works as expected. We sent 3 discovers, 1, 2, 3. These are the 3 discovers that we sent. But those discovers only went to the good DNS server, or DHCP server. And the bad one didn't receive anything. This is good because the guy sitting on the wrong side of the network trying to spoof DHCP will not see those discovers because he's not trusted. But now we have only this one here. But now I need to analyze why it didn't give us an IP. Um, how can we do that? Let me go back to my my good DHCP server. One thing I like to do is probably to let's see, config terminal, logging console. So we're going to enable debug. Let's do debug IP DHCP server packets. Or maybe, do I go with packets or events? Let's just do packets. Let's go ahead and send that thing again and see what we have here. Reload workspace interface. Tablet ID for when. So we receive client VPN is not important. Relay workspace interface packet tablet. Relay information option exists, but oh Jesus! This is where the option 82 is screwing us, because option 82 is enabled on the computer. Again, option 82 is some option that you can enable on the switch to add some relay information, but it was badly done there. So we need to disable option 82. I don't even know how to do that. I've never actually. Let me look it up a little bit here. I'm just gonna show you how I troubleshoot these things. Disable option 82. Actually, let's go trying to figure out ourselves. Let's go on the switch. Configure terminal IP DHCP snooping information. option. Let's get here. No, I didn't do anything. Oh, actually, you can verify and see that option 82 is enabled somewhere here. Um, option 82 on untrusted port is not allowed. There's also another message that should let us know that option 82 is enabled. Jiggling. Let's just Google it. It's much simpler. Option 82 on Cisco Catalyst switch for DHCP Snooping. Enter the global config. Oh no, I didn't want to go in there. Use the IP DHCP Snooping relay information disable. Oh, okay. Relay information disable command to disable it optionally globally. IP DHCP Snooping relay information disable. Okay, let's try that. IP DHCP Snooping relay. I have that command. Or maybe is it on the interface? Let's go interface gigabit 00 IP DHCP Snooping information option allow untrusted. DHCP Snooping information option allow untrusted. I don't know if that's the right command, but let's go back here. Disable DHCP 82 globally. We've seen that it didn't work. DHCP Snooping. Let's look for 82. Relay agent. You can configure device to the agent forward packet between the device. This feature is useful when the client and server are not in the same physical. Relay agent services GIP and information. In the packet forward, the reply for the server is forwarded without the option to enable. How do we disable option 82? It doesn't say that. Relay bounding database. Snooping. Snooping. No, we have nothing there. I think it's, if anything, it might be under information. Option. Let's just activate this option. And I don't know if that what it does, but let's just activate it. Let's go ahead and do another quick request from my computer. I'll do IP DHCP discover. Nope, it didn't respond. Yeah, let's just find a way to disable that option 82. That's what we have to do it. No, it has to do with relay information. No, it didn't work. IP DHCP Snooping. Snooping database agent. Information option. Format. Maybe this is what we need. Nope. Allow untrusted. There is some information option. Allow untrusted. Format. What are we supposed to do with the format? I did that command. Let me see if it does anything here. By the way, let's go back to the good DHCP. What I'm going to enable is debug IP DHCP. Instead of a packet, I'm gonna do events. Go ahead and do this and see what kind of messages we're receiving. Option exists, but jury is 00. How do I change that? Seriously, I've never really dug into that much. Yeah, because that GI address is 0, that's why the client doesn't want, I mean, the server doesn't want to deliver the IP. Welcome to live lab. I need to find what's going on with this thing. Redundancy, show database linkage. Oh, by the way, I can show you the database already because we should have a database built here where I can do show IP DHCP Snooping database. Oh, we still don't have much here in terms of successful transfer and so on. Is that right? Yeah, we have no binding either because we haven't had any successful DHCP address. We only have that. We only have this device that is, oh, this. Wait. Snooping 1, option 0 on untrusted port is not allowed. Maybe I need to go to the gig 02 and allow that, do some kind of command related to option 82. Configure terminal interface gig 20 IP DHCP Snooping. What do I have? Information option allow untrusted. Let's try that. What is the message? It's nothing. Let's try this. Discovery. Inconsistent relay information. That's our problem. Inconsistent relay information. Let's grab this and let's Google this command or this log message and see if we can find anything that can help us. I'll go there and just look it up. Solved. Given that the access switches are only switches, you need DHCP snooping turned on both globally and the VLAN, correct? In particular, you don't need IP helper. No, I don't need IP helper, actually. Correct, the IP helper address statement that will be necessary only the switch where performing inter-VLAN routing. I don't see anything there that I'm supposed to do. Let's go back to another resource. Nothing, VLAN. Try adding the global command IP DHCP relay information trust all. Let's try that. This will ensure R3 to accept DHCP requests with a 0. Okay. IP DHCP relay information trust all. Let's try that command on our router. It's the good one. Let's do configure terminal IP DHCP relay information trust all. Oh, I'm a little optimistic. I feel like it's gonna work. Let's go back to the PC. Oh, it worked. Perfect. We have Dora completed successfully. We have an IP address. And of course, we've made a point here for the good and the bad DHCP, the good and the bad DHCP. Look, with all the transactions that we are doing now, the bad guy is not seeing anything at this point. That is the guy sitting here, because he's actually sitting on an untrusted port. He doesn't see any of the discoveries, anything that's going on. So first of all, the point of this live is made here because the bad guy has no power to do any kind of DHCP transaction. He doesn't see it. And also we were able to fix the problem we were having with the GI address that was 0. Now we just configured our router to trust everything that is coming on the trusted port, and it's now able to deliver our IP address. The next thing I want to show you is just to do some show command on the switch to show you how you can see all the different details. On a switch, for example, I can go show IP DHCP snooping. You can see that we have the port 00 that is trusted, but we also have the port 20 that is not trusted, but it's there. It's doing a transaction as an untrusted port. And if we do IP DHCP snooping database, we don't have much in the database. Anyway, if I go DHCP snooping binding, this is the table that I told you about that is keeping the MAC address, keeping the address, the lease time, the type, the VLAN, and the interface. So with this, nobody else can come in the network claiming to be me or to have this IP, because this table, the binding table, will show us where this IP is supposed to be, what is the MAC address for this IP, and what port is supposed to be connected in what VLAN. That's how you secure your network. And I'm actually glad that you were able to see me struggling to find that option 82 relay information thing. And that's how I resolved it. I think that's all for today. I've been live for a while now. It says option 82 is enabled. It says where? Oh, yeah, it's enabled, but we are not inserting any information there, and we instructed our router to trust everything. So that's why, even though it's enabled, it doesn't affect us anymore. But the good thing to do would be to either insert some information in there that is correct, or to just disable it altogether. But we don't have time to go into that. That'll be all for today. Thank you guys. Finally here, Le Réveil pour le Changement TV. Merci beaucoup. Thank you so much. I think that's all for today. Thank you for watching. And if you like the video, make sure you like it on YouTube. If you are on Facebook, let's see. Oh, I haven't checked Facebook in a while. We have Kari Migdin Rodrigue. Please, what is the role of lease? Okay, lease is actually the length of time that an IP is assigned to a device. Let's say, because I said lease 1 day, normally after 1 day, the device is either supposed to renew that lease again and have the IP, or if 1 day I don't receive anything from the device is not responding, I'm going to consider that device being out of the network, and next time somebody else come, I can give them that IP address. I think that makes sense. Let me just make sure my music is not disturbing here. So what I'm saying is, like in very large environment, let's say you are in a stadium. The stadium, you can have 20,000 people. So you need to make sure that your leases are really short, so that when you lease an IP to somebody, it's maybe leased for 4 hours. After 4 hours, if that person is not on the network anymore, that IP can be assigned to another device. Because if you do 1 day, all the leases will be piling up for 1 day, and then at some point you will run out of IP addresses. That is called, it's also some kind of attack. It's called DHCP starving, I think. Yeah, where somebody would attack your network, grab all the IPs, like lease all the IPs, and now you have no IP to give anybody anymore. So that's some form of attack. But you can have it in normal life if you set your lease too high, where you have new devices coming, but there's no IP to give them. That's a good thing. We also talked about it. I mean, on the CCNA course. All right, guys. I think that's all. Just keep going with the music. Thank you for watching. Awesome tutorial as always. Thank you, Frankenstein. Very nice done. Thank you so much. No IP DHCP snooping information option. No IP DHCP snooping information option on the switch or the router. Let me stop the music again. I feel like I'm not gonna go out today. Let's try that. No IP DHCP snooping information option. Let's try that. So now let's go on the router and do no, remove that. Let's see if it's gonna work now. Oh, sorry, I thought you were sorry guys, I didn't mean to do that. I don't know, my buttons here, I'm just tired. So I'm supposed to go to my PC and try to do IP DHCP. Nice, it works. So thank you, Rabeg Mohammed. Yeah, so when we do no IP DHCP snooping information option, it's going to remove that and we don't have to, okay. Yep, DHCP found everything. So it works fine. So we can either disable the DHCP option or enable our router to trust all. Thank you. That's what I like about the live. We can interact. DHCP exhaustion is what the attack is called, I think. There's something also called starvation. Let me look it up. DHCP starvation attack. What is DHCP starvation? It's just CBT nugget. Let's go on HP. Enabling DHCP starvation protection. Yeah, it's also called starvation. I don't know if it's called exhaustion, but let's just look it up here. Exhaustion. Also known as okay, they're the same thing. Perfect. See, we're all learning. All right. That is the same thing. S dot, thank you. Guys, if you like the video, make sure you like it, make sure you share it, make sure you like the YouTube, you support, you comment. If you watch this after I was live, make sure you comment, make sure you do anything. I'm able to respond to your comments, and also always a pleasure for me. This time I think I'm gonna leave. Thank you guys. Have a good evening or good night, wherever you're calling me or you're watching me from. You have 2 fixes for this. Disable insertion of 82 on the switch via global. Perfect. Thank you, sir. Thank you, Rabeg. Yeah, just leave me in the chat before I leave. Where are you watching me from? I'm always amazed to see how we are scattered across the world. Is what the tag is called. Thank you, guys. And I will see you in the next one. Next one, I'm gonna talk about some cool stuff on the FortiGate. Hit the like button, guys. Yes, hit the like button. Destroy it. All right, perfect. Thank you. I'll see you in the next one. Bye.